This problem, we're presented with a compound inequality, x plus 4 is less than or equal to negative 5, or 2x plus 3 is greater than or equal to 0. This or doesn't mean that we get to choose whether or not we solve one of those problems. We have to solve them both. To do so, let's kind of reorganize our work so we have two, think of them as two problems. Here, let's get rid of that plus 4. The opposite of plus 4 would be to subtract 4 from both sides. That would give us x is less than or equal to negative 9. Here on the right, we have to get rid of the 2 and the 3. Since we want to get rid of the 3 first, the opposite of adding 3 to both sides would be to subtract 3. So 2x would be greater than or equal to negative 3. Next, we want to get rid of the 2, so I can divide both sides by 2, and I get x is greater than or equal to negative 3 halves. When we graph this, we can first find negative 9, and we want to put a closed dot there because of our inequality sign. We have to ask ourselves which way we're going to shade. Well, we can ask ourselves, is x bigger or smaller than negative 9? Well, x is smaller than negative 9 because it's a less than or equal to, and the numbers that are less than are over here on the left. Over here at negative 3 halves, again we have a closed dot because of the inequality sign. Is x bigger or smaller than negative 3 halves? It's bigger, so the numbers that are bigger are over here on the right. So that's our number line graph. To write that in interval notation, we start at negative infinity, and it goes all the way to negative 9. Since it includes negative 9, we'll use a bracket. Or we can use our union symbol, negative 3 halves. Again, it's a bracket because it contains that, all the way to positive infinity.